Okay, so this is homework 10, problem 2. And so we are given that x of t is a Poisson process. And we're also given that the expected value of x of where t is equal to 9 is equal to 6. And we're asked to find the mean and variance of x of 8, given this bit of information. And so we know that the expected value of x of t, where x of t is a Poisson process, is equal to lambda t, as we did in problem 1. And so simply then, we can solve for lambda, whereas we know what t is, that being 9, and we know what lambda t equals, that being 6. And so lambda is simply just 2/3, because it's 6 divided by 9. To find the expected value of x of 8, we just simply plug in these two values. We know what lambda is and we know what t is. So in this case, t is 8, not 9, and lambda is equal to 2/3. And so the expected value of x of 8 is just equal to 16/3. The variance of t is also equal to lambda t, because the variance and the expected value are equal to each other when the process is Poisson. And so we just plug this in again, and we notice it's the same thing. So the variance is also equal to 16/3. In part B, we are asked to find the probability of x of 2 less than 3. And so we know that for a Poisson process, that the probability of a random variable less than a certain number is equal to the summation up to that number times the Poisson process, where it's e to the negative t times lambda t times to the ith, or in this case I, because this is divided by I factorial. And so when we're given that x of 2 is less than 3, we just plug in for when t is equal to 2 and k is equal to 3. So we just simply just plug in, and we get our lambda t is equal to 4/3, and so we get 4/3 there. And this is the summation from 0 to 3, because we have less than 3 here. So it's from 0 or less than or equal to 3, so it's 3 inclusive. So summation from 0 to 3. And so we just do this summation for increasing k from 0 to 3. And so this is basically just a plug and chug at this point, and I'll let you evaluate what this equals yourself, and you can check, because it should come out to around 0.955 when you finish it. Okay, so part 3, we are asked to find the probability of a random variable when t's equal to 4 less than 5, given the random variable where t is equal to 2 less than 3. And so just using the generic conditional probability identity, it's just simply the union of these two divided by the probability of x of 2 is less than 3. And so off the bat, we already know what the bottom is, because we literally just solved it. So it's going to be this value, this union up here, the probability of this union up here, divided by 0.955. So the question becomes, what is that value up there? And so, like we said before, for the first component x of 2 here, we know that t is equal to 2. And so let us set a equal to the random variable when t is equal to 2. And then for t equal 4, like I said, this is the gap. So we know it's like from 0 to 2. Similarly, when t is equal to 4, we know that's from 4 to 2. Because if this wasn't from 4 to 2, the intervals would overlap, and therefore this wouldn't be independent anymore, which would make it a lot harder to do this problem. And so A represents now the number of Poisson points in that interval from 0 to 2, and respectively B represents the number of Poisson points in that interval from 2 to 4. And so the probability of them, when we substitute in this random variable notation of where A is equal to K1, where K1 is equal to the number of occurrences during that time frame of 0 to 2, and K2 is equal to that number of instances in the time frame of 2 to 4. And because we know that these two intervals are not overlapping, that these are independent in fact, the probability can now be split to the probability of A is equal to K1 times the probability of B is equal to K2. And so we know that we could just plug in K1 for the generic formula of the Poisson process. So like say hypothetically, back up here. And we know what t is equal to. Because t is equal to t2 minus t1, and we know the interval here is from 0 to 2, then our t is also equal to 2. And so it's just 2 lambda. I already combined the 2 here because when you multiply e to the negative 2 lambda times e to the negative 2 lambda, you get e to the negative 4 lambda. And then you have the respective 2 lambda to the k, 1 or 2, depending on whether it's equal to a or b. And then these are two multiplied by each other, and you get this resultant. So for our summation, we have to do it with respect to the other. And so we know that a is going to be less than 3 because it was given here where a is equal to x of 2 and x of 2 is in fact less than or equal to 3. b is equal to x4 is less than or equal to x of 4 minus x of 2. And we know what x of 4 is equal to because x of 4 is equal to 5 here, because x of 4 is less than or equal to 5. Minus x of 2, and we know x of 2 is equal to a. So this can be rewritten as b is less than or equal to 5 minus a. And so the probability of a is less than 3 and b is less than 5 minus a is simply just the summation of, well, you could do this, I kind of did a shortcut here, but it would be the summation of both times each other, which is just the summation of the products of each other. So we just get the summation of k1 equal to 0 to 3, and then k2 is 0 to 5 minus a, like the bounds we had before. And like I said, we know what the expected probability of x2 of 2 is less than 3 is equal to, because we just solved it in part b, and it's equal to 0.955. And so our answer is simply just going to be the union of for when x of 4 is less than 5 and x of 2 is less than 3 divided by 0.955. And that is your answer.